My name is Zane Everett. I will be the moderator for this panel, talking about the indie experiences in artificial intelligence. I suggested this panel because I am an indie developer that specializes in AI. And over the course of my career doing so, I've run into a handful of things that I'd like to share with everyone, and also like the experiences of these two guys to my left and right. Um, I'll start out with a little bit more information about me. I work at Motion Reality Incorporated. We make full body tracking virtual reality games. So, in that endeavor, I am working to create a framework for Unity to work with our motion capture, but I also work with artificial intelligence from time to time. Before that, I spent 5 years at Cogent Education, making educational games. From time to time, I worked on artificial intelligence in that. Went to UGA to try and obtain a master's for artificial intelligence. And we'll start with Karthik.
Hi, I'm Kartik. I'm the one of the few people behind Twin Cop, and I am less on the academic side of AI, more on the practical implementing it into your indie game side of AI. I've had a lot of experience in integrating a variety of AI techniques and stuff in the various projects and games that I've made. And yeah, I want to try and sort of speak to that end of the experience, less on the sort of machine learning and the more academic side of it, more on the like, what can you do with your AI to effectively implement it in your game so that it like creates interesting and unique behavior.
Yeah, and I'm Jason Hillhouse. I work at a company up the road called You Are Here. We do lots of interactive installations for companies that are looking for just interesting apps like touch screens or augmented reality apps to put on the Play Store, or anything for a projection floor where you walk through it and little flowers will rise up by your feet. Just weird stuff that uses Unity, basically. And yeah, recently we started looking into machine learning for pitching to clients things like counting how many people go through their booths at a convention, stuff like that. And I'll be talking about the challenges and practical applications of using it in that kind of facet.
So yeah, generally you probably caught it from these two guys. We're talking about indie. That can mean lots of different things. In this context, I'm really approaching it from small teams. Well, presently where I work has a workforce of about 30, which is kind of getting large. Our actual development team for software is about 6 people. That's still fairly small. These two work for small teams. This guy bootstrapping with 2 to 4 at different times. So yeah, as starting out, get to know you guys. What was biggest inspiration for you in pursuing learning artificial intelligence?
So for me, it was, I'll be honest, less inspiration, more sheer utilitarian need of it. I was just like, hey, I think the first game where I had to sort of figure out how to do AI in, I'm trying to remember which one this was. I think it was like one of the projects that I did when I was at Georgia Tech in VGDev. We were making a game in which we needed enemies to do things, and when I first started to realize the importance of actually like researching AI instead of just doing what you think you're supposed to do, is when I was starting to code like, oh, I know what enemies do. They move towards the player and they attack it. And I coded that, and it was terrible. It does not work if you just think in such simple terms like that. You have to really, really dig a lot deeper into the AI tools at your disposal to create good behavior, essentially. And then from there, the first project that I used AI in was garbage. But after that, I started to make less and less garbage games and better AIs, and to the point that I think, and I'll talk more later, I guess, the AI in Twin Cop has become something that I'm very, very proud of and very, very excited to share with everyone.
Well, for me, it was really inspiring. It was inspiring to see all of Google's work and OpenAI's work on making bipedal ragdolls basically come to life. I'm not sure if anyone's seen that video of the ragdoll basically doing the fist pump as it runs really fast. It didn't know anything about that. It was just a ragdoll that was given basic physics and this algorithm, machine learning algorithm that they're using, and eventually after several thousand generations, it learned how to walk on 2 feet, it learned how to run over obstacles, and it learned how to hold its balance. You could throw boxes at it, try to push it over, it still works, and trying to find an interesting application for that in terms of games was really what I was hoping to do, mainly with the physical simulation side of machine learning, which I guess, I'll show you what I came up with a little later on the big screen.
So for me, my biggest inspiration really came in undergrad. My professor, Dr. Robert Moore, focused on artificial intelligence, and after doing a handful of his assignments for our AI class, I decided that was a route that I wanted to take. Specifically, it was the first function that we had to do for it, which was a state machine, and it was called Miner Bob. And Miner Bob had a handful of different states he could iterate through based on different variables that went into him. I found that exhilarating to see behavior out of something that I made that, in a very rudimentary way, felt human. And I decided to continue pursuing human-like behaviors out of artificial intelligence for video games. So let's move into describing some of the AI that you've created for different games, what techniques you used, and just fun stuff like that.
Sure. So yeah, I'll sort of break down some of the challenges and solutions that we came up with for Twin Cop to sort of give everyone an idea of what it was like trying to figure these things out on my own. I will say that a lot of the stuff that I learned to be able to do this came from taking an AI course when I was at Tech, which was just a game AI course, and it was taught by a friend and very inspiring person, Matthew Gusdile, who, if you haven't heard of his work, check him out. He's making AI that will eventually make our jobs obsolete, because he's making AI that will make games. I'm not even kidding. It's really cool. But so in taking that course, I learned a lot of these tools. I'll start with the problem that we were trying to solve in Twin Cop was essentially, it's a top-down twin-stick shooter, and I once again, in my foolishness, tried to do the most obvious thing, which is make enemy go towards player and shoot at player. And what that caused was this blob of enemies that would just sort of chase you around, and you would just sort of circle strafe them, shoot them, and they were all gone. And you were just like, well, that was easy. And for a long time, I was just sort of throwing my hands up in the air, being like, well, I guess that's just how twin-stick shooters work. It's just, I don't know. Until I learned about voids, and then I learned about more complex forms of nav meshes and other things like that. And I think implementing a void system, which I'll go into depth in a second, for this was really, really impactful in creating more interesting gameplay. And essentially, the Cliff Notes version of what I'm just calling it voids. Is there a better name for it? Voids flocking, essentially, is what it's used for.
Yeah.
Steering behavior is also another term that is used for the same idea.
Right. So generally speaking, the way that I implemented it was every single enemy has like a repulsion amount, how much they want to push other enemies away, and an attraction amount, how much they want to come towards other enemies. And this sort of balances out and makes sure that no enemies get too close to each other at any given time. So they spread out, but they do still sort of move together. But one of the things that really made it feel intelligent was pairing this void system that kept the enemies separated and kept them less clumped up, was assigning a set number of like flanking positions on the character. So as you are trying to run right and there's two enemies ahead of you, one will be like, cool, let me just go straight towards the character. That other enemy will realize, hey, this one's going towards the player, let me try something else. I'm gonna go in front of the player. And then that creates this interesting gameplay of, you tried to circle this one, that one got in your way, oh, we need to shoot at this one, oh, that one's still chasing us. And just by that one simple change of just like, hey, don't have 2 or 3 or more enemies following the character in the same way, just completely changed the entire gameplay and feel of the game. And it was amazing how, and that's like the most, as far as AI techniques go, simplest that you can do. Mm-hmm. And it was hugely impactful for us.
Yeah, for me, I was trying to basically just get walking to work. It's one of the really most interesting problems I've seen solved with machine learning, starting off with a ragdoll uses the same physics you've seen in any video game engine, and then slowly just have it teach itself how to stay up. I guess I'll just show the videos here of what I ended up with. So basically, it's called reinforcement learning. You give the AI rewards and penalties, basically. That is basic, and most basic. In this case, I basically just said, if your head ever hits the ground, kill it, you have a -1 penalty, basically. And then if it ever goes forward in the Z plus direction there, it gets a reward. So it knows that's a good thing. It knows what's good, and it knows what's bad, and then it uses the actual algorithm in the background to process random movements for the next iteration. So it's slowly trying new different things randomly to see what works, and it knows what works because I'm telling it reward or penalty. And in this case, I didn't really tell it that moving its legs a whole lot was very important. So it did what I told it. It kept its head above the ground, and it went forward. But it looks not so good right now. It's just kind of limping. So then, told us to move it. No, thanks. No.
Of course, Windows does.
So then I told it, okay, you got to move your legs, and going faster is even better. So yeah, it learned that, and I never told it had to move all of its legs, so I figured it would just use its front leg as kind of a crutch just to keep it going up, to keep it up. And yeah, and currently this scene right here, actually what it's doing is it's got 10 agents, as Unity calls it, and it's using all 10 of them to slowly get information over what's happening, what's working with this new iteration of learning that I'm giving it right here. And so eventually you tell it, all right, I want all your legs to be moving. And it starts to look more like a real spider. The funny thing is, I don't think it moves as fast as the last iteration, because the cool thing about these sorts of reinforcement algorithms is that they give you new ways of thinking how things could move in nature. Because it's like, why don't spiders just use their eighth leg as a balancing thing? And yeah, so stuff like this is really what I do it for. I guess the end game would be, if you've ever played a game like Monster Hunter, it would be sort of a very interesting enemy to fight that can physically keep itself up, with everything in the game being a physical weapon. So trying to catch it off balance, hook its ankle in a trap so it can't move, and it's all done in real-time physics. It's an interesting gameplay problem for me. So researching stuff like this is part of that.
If I may piggyback on that, I think that this kind of work, this kind of procedural animation is going to be a big part of the future of games and indie games in particular. AAA games, I think, are going to take a little bit longer to catch on to using these things because of how awkward it looks. But if you've ever played a game called Grow Home, that doesn't use AI to move the character, but it does use procedural animation, and it results in just these really funny and awkward, but also interesting not only gameplay moments, but also just visual moments where you see this character just suddenly like whip its arm around and grab something. You're like, oh, cool! It like knew what I was trying to do when I pressed the button.
Listening about your statement with the AAA games probably taking a bit longer to implement, and do you think innovation coming ground up from indies on this? However, the big guys are starting to look into it. The biggest identifier of that is that this past GDC, there were at least 20 talks specifically on machine learning, this style of artificial intelligence. The previous GDC, there were less than 6. So that's a huge boost, and the big guys really interested in it. But for me, types of stuff that I've worked with, there's lots of different things. I've worked with Boids, I've worked with other types of navigation, I've worked with some machine learning. One, I guess, obscure machine learning technique that I used was for a game that was about a beehive. I used state machines and steering behaviors for that beehive for some basic stuff. I had a deal where I was trying to teach basically the soldier bees, the bees that kind of guard the outside of a nest, how to deal with different types of enemies in a very simple mechanism. One of them start with no knowledge and eventually go up to some knowledge, because the idea was for those bees to be able to pass that information along generation from generation. I used a technique called case-based reasoning. This is interesting because what it does is it stores a state and an action and a result as a tuple within a file, and it is able to look at what it expects to be the best result out of the current state of the game and the action that they could potentially take. There's good reasons why it's fallen out of favor in artificial intelligence. If your state and your action base is too large, then you have a huge set of stuff to look up, and that's expensive to do. And this is why it's fallen out of favor. But for my set of possible actions that I had, that was some real basic learning, it was a really small file that I had to look up. and so it worked for this situation. That's going to be the biggest thing that generally you hear from me in any talk when we talk about tools or techniques or anything like that. They're all tools in your toolbox. You don't use a screwdriver to pull up pavement. And there are certain tools that are used for certain jobs, and knowing what jobs to use those tools for is important. So then we're going to kind of get into what it's like. We've talked about some different techniques, what got us into this. Let's really talk about what it's like doing AI at a small place where you've only got a handful of people. There's lots of competing priorities. Wouldn't you take that away first?
Sure, yeah. I think that this question in general, I think, applies to a lot of struggles that people have in indie game development, which is like, we only have, in my case, 4 of us. We only have so much time because all of us are doing full-time jobs to be able to support our indie business. We only have so much time. What are we going to spend it on? Are we going to spend it on art? Are we going to spend it on more levels? Or are we going to spend it on that weird intangible thing called AI? We're going to spend it on like how the enemies move because, hey, last I checked, the enemies are moving towards the player and shooting at it. So that's fine, right? And I think that it boiled, for priorities, it boiled down to us taking the game to cons. I think the very first time we took Twin Cop out, it did well. It was great for us because that was the first time we realized that we had something really great in our hands. But we also realized by watching people play that there was an optimal strategy. If you see people playing your game, and I'm speaking specifically for coding enemy behavior, if you see people playing your game and your enemy is being controlled by some sort of rudimentary AI, and you see that there is an optimal strategy for your game, which is for some people what they might want, for some people maybe not what you want. In our case, we didn't want there to be an optimal strategy. We wanted there to be some experimentation with the gameplay and some challenge to everything that you were doing. And so we knew that the core of the gameplay, the entire game is about moving around enemies and shooting at them. That needs to be fun before the art looks good, before the level design is perfect, before the sound is great. Just what you do from the beginning to the end of the game needs to be fun. So that was one of the things that told me, like, okay, I need to stop everything else that I'm working on right now and focus on this. I need to focus on the AI because this is the thing that's going to impact so much of this game. And I think it's challenging to think that way, to think that you need to not focus on the big flashy stuff that everyone sees in your game, which is, wow, but I could be spending this time designing a huge brand new level with all these mechanics and all these cool things. But if your game interacts with enemies and your enemies aren't smart, your players will notice. And personally, I believe the best AI is the AI that your players don't notice. It's the ones that your players don't even realize is there. And I think that was like one of the things that I realized after I implemented this was that people stopped even commenting on the enemy behavior because they did at first. But now after our new AI system, they just stopped mentioning it. And I was like, I did it. That's it. That's what I wanted. And that was how I knew that's what we needed to do.
That's been my big objection. If it behaves fairly like a human, people won't say anything because it's natural.
Yeah.
It doesn't glare itself as being, well, this isn't normal. This isn't strange. Because it's what we accept and what we anticipate another entity to be behaving as. And best AI, no one sees. And that's a lot for other aspects of game development as well. Sometimes the best art is really that which you don't really notice, but if it was wrong, you would notice it because it creates an ambiance. And it's the same thing with AI.
My first job was doing character animation, and that is definitely the case. If anyone ever notices your character animation, maybe you didn't do it right.
Yep. So.
Okay. What was the
next question? Working on a small team. What kind of
right.
complications have you had? Just,
Yes.
Priorities.
The hardest thing is explaining why machine learning is even is relevant. Really, it's really tough, especially in a more in a marketing-facing firm where I work. And so pretty much everything people want you to make for a company like that is going to be, flashy, very unique, very, brand-based. And machine learning is very specific, very static in the types of problems that it can solve. But it can solve very, very hard problems. But it's problems like how many faces are in this audience right now? How many of them are looking at me? How many people are smiling, frowning? How many people have their eyes closed, eyes open? And so explain that to a marketing or a sales guy, It's not the most, the creative explosion doesn't exactly go off in their head when you describe the things machine learning can do, but there are very interesting things actually that ends up being able to do. I think my last video here. So for my company, we have just booths. We do lots of booths for conventions, and analytics for something like that is super important. So what you're seeing right now is a machine vision algorithm that basically just detects chairs, tables in red, person in white. That's me walking around, and I've actually taken that with a camera, and inside Unity I did a 3D scan with a Google Tango, and just for making it easy to know what you're looking at, and basically just triangulated where that camera's looking, and taking the 2D space that the camera sees you in and translated that to the 3D space on the right in the Unity scene. And things like that is super important for being able to, are super useful if you need to know how many people are going through a 3D space. The Chinese government actually takes they use a lot of this right now with their surveillance state they have going on. And it's, yeah, it's useful for convention booths too. So yeah, being able to explain it, I feel doing it visually, I guess, is the most important at my day job, because it's important to be able to show them what machine learning can do, because what it can do on paper isn't always very apparent. So yeah, stuff like this, being able to visual object detection is where I've been focusing a lot right now.
I'm going to piggyback on that based off the conversation you and I had before this talk, which is about visualizing your AI.
Mm-hmm.
Do it and maintain it, and don't lose it. It's a mistake that I made on TwinCop that I want to make sure no one else makes as well, which is when you develop a really cool and intelligent AI system, and to do that, you will inherently need to build some tools to see what your agents are thinking. Make sure you maintain those tools, and make sure you maintain the ability to do that, because it'll not only help you debug issues later on, but it'll also help you show off all the cool stuff you're doing.
Yeah. Show and tell.
So in my experience in dealing with different priorities at companies that we're working with, it's depending on where you're at. So if you're at a bigger place, you're more likely to be specialized in it. But if you're at a smaller place, there's just other conflicting priorities that have to take precedence, and it depends on the nature of the project. But that's not what you want to do. You want to do AI, because that's what you're here for. That's what you're excited about. But realizing where you can fit things in, even if it's not gameplay AI, to help out the other creatives on your team. What can you do to help streamline their process? And a lot of you talk about building tools for your AI. Definitely do that. But that skill set also translates into building tool sets for artists. And I had experience before with other games that were being created for the educational company, and the level of AI that was needed in most instances was rudimentary. Personally, that was a little bit of a letdown, because that was what I signed on to do. My first game was on it, but as we move forward, it was just less of a priority for the company. This is going to be a reality of small places. You may have games that just don't need as much AI. Being well-rounded in other things is going to help you keep your job, but then when something, you can say, well, this is a good place for that. Make your pitch. How will this improve the gameplay? Talk in terms of gameplay.
Mm-hmm.
Talk in terms of how much this will speed up time for an artist if you create this tool this way. All of these things, being able to explain what you do, which is difficult, and having these tools allows you to do it. Though another complex thing is finding the time to make these tools to explain it is also just as much of a crux of being able to do the AI that's really cool. That's where you get efficient at everything else that you're doing, and you do get a tiny amount of free time. And that's when you work on these things.
Yeah, this is all free time stuff. It's very difficult to convince a client to pay for R&D, so you end up doing it basically on company time, typically. Yeah. And
it's even difficult to convince your superiors to take time to do R&D when you could be making things that lead to a product that sells and makes money.
Yeah, even my programming lead, it was stuff. Yeah. So make some cool game AI.
So, I guess in that same area, so you've come up with an idea to say that I think this is how this will work. What do you guys do if you get pushback? I don't know if you'll get this because you're kind of at the top of your team. But so do you get pushback from other members of your team? What do you do on that?
Pushback in terms of like I want to accomplish something and
Yep.
Yeah, not really. It's the perks of being your own boss, I guess.
Right.
But that doesn't mean that I don't, always run everything by the rest of the team first anyway, because it is only the four of us. We decided when we started our company that we were going to not try to do the whole majority rules. It's just the four of us. We should be able to reach consensus on everything. If we can't, then there's something wrong. No, we haven't had any pushback per se, in the sense that any idea has been completely nixed down. Most ideas that we've been we're like, oh, let's try implementing this. It's always a matter of, yeah, let's try it. As long as it doesn't, completely negate everything else that we're doing, let's try it. There's no harm in trying. Until you try, you don't know it's going to work. There's a part of TwinCop upcoming that I recently pitched to the rest of our team that is going to be super experimental, using Markov chains to have a sort of weird scripted conversation between two characters within the game.
Fun.
It's going to be really, really artsy and really weird, and maybe it'll work, maybe it won't. Maybe this is the first and last time anyone will ever hear about this. But and that's our strategy. That's our personal company strategy and behavior, is that we try everything, but we don't put any bets on anything. We don't put any risk on anything. We just say, if you can try that and not put what we currently have already going on at risk, try it. And that's about it. That's why we don't have much pushback. But that's also because right now none of us are depending on our studio for money. We all have our own full-time jobs, and this is just cherry on top if it succeeds. So don't do what I'm suggesting unless you already have enough money to pay rent and all that stuff, because this strategy probably won't work if you need to get a product out the door and make money on it. So
a long time. This is very involved. It's a very involved process. Takes a long time to wrap your head around all the concepts that go into this. And oh geez, this was maybe 6 to 8 months ago. I hope I still remember it all when I jump back into it next month.
So what about you? Have you had any projects or ideas where you've given thought to it, you've explained your idea well, and you've received negation from superiors or lateral?
It's more of everybody wants to put their input into how a product should be. So you see something, you see another company make an app that's sort of AI based or does machine learning to track where, say, a ring on your finger is, and you can just pick rings from a menu and then have them just show up on your finger from your phone, like a little app like that, stuff like that. That's like a baseline. But then, if someone else in the group wants to say, well, could they just flip their hand over, or could they don't know exactly understand what the machine learning can do. So it's really hard to have a discussion with a non-technical person about it, who where in other realms of tech, they'd have some pretty good input, some good ideas, but machine learning, it's very restricted. It's very kind of simple of what you can do. I think the example was if you is the difference between algorithms that are used to track where your fingers are versus algorithms that are used to track products that look the same, sort of your hot dog, not hot dog style stuff. And they're all inside the giant Venn diagram of AI, but they're in different groups and different research that's been done into AI. So yeah, I would just say getting the creative people and non-technical people on board is where the pushback probably comes the most, because they're going to want to, they got their crazy ideas, and it's similar to what they've seen another app do or seen what another company has done, but still just outside of reach of what probably you and another programmer could do in 6 months. So yeah, just having that conversation with people who don't have a very deep understanding of machine learning is where most of the pushback comes on my end. Yeah.
I would really second that, and ways of overcoming that. Videos help, finding other products that are similar. For leads, white papers can help. Not the full white paper, the summary, the abstract and the summary. That's where you're going to get, because they're not going to be able to get through the whole paper. But if you can give them the this little bit, this is what this research team found. This is their results from doing this thing. I know how to do this thing. that can get you a little leeway. But sometimes it is just a reality that time priorities are going to override what you think is cool, even if you think it's best. Um, many of these decisions are done by committee, and sometimes that is for the best. Sometimes it can also feel like you think that it's for the worst. That things could be done better. You know, this is just going to have to be a deal where you don't take things personally. Um, People that talking and don't have access to the money, you have access to the money. But for people that don't, um, that's not your decision to call. You can give your best input, but don't take it personally.
And I'll just kind of curious. Raise your hand if you are a coder and you like love doing new things in coding specifically. Like,
Yeah,
okay, that's good. That's what I expected most of the
Yeah.
audience in here would be. I kind of want to sort of like post a question, if I may.
Go for it, man.
Which is, and I'll start by answering myself. Is like, when should you not use AI? I feel like
Ooh, that's
that's
good.
as important a question as when to use AI. Because more often than not, whenever I work with a programmer who is a passionate programmer who likes to use cool and new things, I'm always invigorated by that. I think it's really great and cool to be able to work with new cutting edge technology. But I also think there's a time and place for it. I think there's a time and place to be experimental and to be putting that like cool cutting edge new stuff into the product. There's also times when, hey, maybe the dumber, simpler solution is actually the best solution. And in our experience, we got a lot of advice on like how we should code the pathfinding for the characters in our game. We kept being told like, oh, why don't you just use like Unity's nav mesh system? Why don't you use this system? Why don't you use that system? This one's more flexible. This one's more that. When in reality, it turned out after testing some of these other systems, the one that ended up being the most reliable, easiest to debug, and fastest for us to get the product out the door with was hand-placed A-star nodes, which is like the oldest trick in the book as far as game dev goes, but got the job done. Huh?
Though that is an AI technique.
It is an AI technique, but it's not. Yeah,
simple.
it's not like I'm arguing against like doing the new cool thing just because it's a new cool thing. And I think it's exciting to do that, and it's great to do it on R&D projects and to do it on personal projects. When you're working on a larger project with other people, with timelines and that kind of stuff, you also have to know when to dial it back and when to decide, okay, is it actually going to save us time, and is it actually going to get the product in a better state if we use that one? So I'm curious what your thoughts are.
I completely agree. It's still the same deal. Toolbox. Sometimes you have deadlines. Sometimes the best way to get an idea is really a simple one. That is just a judgment call that you kind of get with experience and using the things and failures. You've had failures. You've let other people down. You recognize when and where that is, and you start to identify, especially if you did something new and unique. But just having an understanding of what techniques are out there and when to use them, and it is definitely true. Sometimes the simpler solution is absolutely better. I want to bring up a specific example, but unfortunately one's not coming to me right now. Because I know it's a trick. How about this? I'll suggest a video. The GDC 2018, if you have it, AI tips and tricks. If it's not out now, I think it's something they do every year for 2018 is not out now. They do it every year, but it also will come out within the next year. So if you just check out the GDC Vault, they give great tips and tricks about how to use different tools in your toolbox to keep things simple. Here's a specific example for doing something really, really cool through a simple means is influence maps. These are just textures that are laid out on your space. It's also very interesting the fact that it allows art design people to marry up with complex coders, because you can do neat things that say, all right, now this on art side, this area is painted as forest, and only certain things live in the forest. This is the only place that they'll ever navigate through, and it's just a texture. And you're pulling it, and if something starts to move out of it, they'll move back in. But the other neat thing that you can do is do area of control effects through code. This action happened here, now I'm going to modify the map. and it's something that is very easy and simple to recreate that artists can somewhat understand because they get what a texture is, and it's a great way to get them on board for what you're doing. This is a much simpler deal than trying to do a vision machine learning of the area.
Yes. Oh man.
And it's just a simpler technique that works and would take less time to train something.
Hmm. Yeah, specifically with machine learning, is the training is the most engrossing or the time-consuming part of it, and you're not always sure what you're going to get. Um, the strangest thing I think about AI, or machine learning part of AI, is that we are using algorithms that we technically don't know how they work. They train themselves, and so yeah, and so that means you don't necessarily know what you're going to end up with. You're kind of just, this you're like a programmer parent, just kind of like guiding your algorithm along, hoping it goes for the reward you want it to. It might not even get close. It may nail it. You're not sure, and hopefully it ends up with a good solution, so you can end up with your fist pumping biped running down the hall, and yeah, mainly just. But yeah, that's a very complex example. And then in terms of like, I'm working on a game right now. It's just a very simple semi-dungeon crawler, and it's very AI based. I have lots of states that I use, lots of chase behavior, lots of follow behavior, and sometimes maybe during a really complex boss fight, I want very complex AI that keeps track of everyone's health, keeps track of everyone's position, what their state is. But that's for a really complex boss. If I have that for like a little bat enemy that's does anything but just like fly at you, it's going to be too complicated. It's really a design problem at that point. How smart do you want your AI to be in the course of the game? And it's usually context sensitive. Simple enemies should have simple, predictable AI, because that's the problem solving fun of an action game, is just memorizing that attack pattern. In Dark Souls, when it comes down to it, it's really just about waiting and memorizing the attacks. And once you got it, that's where the fun of those games comes from. It's just the attacks are very simple in terms of what happens, but they're complex in the breadth of what they can do. So it's all about just kind of balancing that depending on what you want your design to be.
And I'm going to piggyback off that about like putting gameplay first.
Yeah.
If this is a game project,
Yeah.
gameplay should definitely come first before you start thinking about what tool you want to use. And I think a great example of this is Doom 2016 did a lot of really interesting AI tricks that are kind of, if you think about it, dumb. I'm trying to remember specific examples off the top of my head, and I might be misremembering some of these, but it's a GDC talk as well, which you can look up on YouTube. It's really, really, really interesting.
Yeah, definitely watch it.
And if you could correct me if I'm misremembering this, but I remember them talking about how they put some enemies to like intentionally sit just outside your field of view. And like if they were outside your field of view, they were less likely to attack you. So you have less frustrating moments of like, I'm getting shot. Where am I getting shot from? And like wondering all that kind of stuff. And there's a lot of stuff that they did that was super, super player gameplay focused, player experience focused, instead of what would a demon really do in this time and moment? Because if they coded it that way, Doom would be impossible, and Doom would probably not be very fun. But they coded it like, what should the player feel? What should the player see, and what should the player notice about the enemies? And you can do a lot of fun and weird tricks like, oh, if the enemy isn't in the player's field of view, then who the heck cares what it's doing? It could be sitting still for all you know.
The other side on that is it saves processing. Because
Yeah.
AI is always hard on processing.
Oh, yeah.
That saves processing.
And actually it's another trick that we're, to be fair, not doing yet in Twin Cup, but it's a planned iteration on our AI system, which is that if an enemy isn't on screen, I don't care where they are on the nav mesh or where they are. So we're not using a nav mesh on our node grid system. I'm just going to put them on the node point closest to the screen so that they get back on screen, and that like will solve all of your like, oh, it got caught on geometry issues and all that kind of stuff. Like, don't worry about making it look right from your editor view inside of Unity. If you're looking at it from there and things aren't looking right, that doesn't matter. Does it look right to the player? Does the player see what they think they should be seeing? That's literally all that matters.
A question right here.
This is reminding me of a friend of ours has been working on a game, and she has all this stuff with like big 3D space because there's like things flying around and stuff, and there's like chunks of like spaceships or buildings or what have you. These have to nav mesh through, and she told us how if an enemy hasn't been seen for, I think she said
Mm-hmm.
spot because she didn't feel like having the nav mesh all the time.
Yeah.
Yeah. There's great shortcuts. Shortcuts are your friend, honestly, in AI.
Mhm.
When we talk about past machine learning, shortcuts, simplifying ways to trick the player into thinking that it's working the way that they think that it is. And that isn't, you want it to behave while it's on the screen as if it feels kind of like a person, but you have to balance gameplay. And sometimes you just do simple stuff that.
She ended up telling us that the AI was a little scary, and we kept telling her, it's like, you created a horror game with giant, like, flying robots here. What are you doing?
Time to pivot the game design.
So, let's see. I wanted to touch on the process of combining art and artificial intelligence because that's a real thing. You can have AI that does things, but if it doesn't pair up with the art and interfacing with artists on how to get that taken care of, you guys have experience in dealing with that.
Yeah, that's. I think that usually boils down to how you've set up your code base. Over the course of the multiple games that I've made with the team that I'm currently with, we've learned the strategy. The organization of code that we enjoy working with the most, which is essentially to have a generic character controller, essentially. And I'm not talking about the Unity component character controller. I'm talking about like a generic character controller that essentially just handles the behaviors that any entity in our game can do. So I'll give an example. In most recently, our team did a game jam, the Game Maker's Toolkit jam on itch.io, which was really fun. And we knew we had these like 2 playable characters, and it was mainly going to be a 2-player game, but we were like, well, for testing purposes, let's make one of them controlled by the AI. And so we needed to code up something for that. And what we did was we coded one class that was essentially allowed you to just call functions to do the basic activities of that character. It can punch, it can move, it can duck, it can do that. And we coded that just to like make it work that way, and then we like tested it in a coroutine to say, can we just call these functions in a row and make it look like this thing is behaving in a human-like behavior? And if that was possible, then we just replaced that coroutine of manually hard-coded behaviors and wrote a very, very, very simple AI. This was a game jam, after all. It was just like randomly deciding, oh, do I move left? Do I move right? Do I punch? Do I duck? Do I block? Because it was kind of like a rock, paper, scissors game. And coding it that way meant that we were able to just sort of like hot swap start out with just 2 AIs fighting. Whenever I wanted to test the game, I was just like, hit play. I'm gonna watch these 2 AIs just duke it out and see what happens. And then was able to sort of like replace that one script with, okay, instead of something deciding what's gonna happen, now I'm gonna decide what's gonna happen. And having one script that just handles all of what the player can do was really helpful for that.
Do you have any instances?
Let's see.
I was gonna say, do you need me to go to think about it, or?
Yeah, I'll probably
okay,
take
that's
one.
cool. So I'd highly recommend learning, especially if you do character animation. That's going to be a thing that you have to interface with if you're doing people like AI. Learn how animation blend states work.
Yeah.
It's going to save you. Learn how to communicate that to your artist, what you need. I've recently been working on a blend tree specifically for creating our navigation for an AI that is using mocapped animation. This has been a difficult thing to deal with. Is in particular being able to communicate what I need out of it has been a shortcoming of myself. I've been working on it and been learning exactly how to, how can we get little loops that you do additive animation or you do overriding animation in certain ways to be able to, say, have your character walk forward at the same time that they're aiming in a different direction. Coding that all, just coding it out is going to be difficult, and learning how animation blend trees work is going to save you a lot of heartache when you're trying to get something that looks fluid. And that's going to be on you, because the animation is going to look fluid straight away, because the artist did it good and they did it right. And then now it's on you to make it look right when it's all put together.
That's why I was recommending the idea of having an extra test class that just hard codes behavior, because if you can test with hard coded behavior, then you know that when that behavior is more randomized, it will also work, because then you can. Yeah, sorry. Go ahead.
Oh, yeah. No, I was just, yeah, definitely. Your finite state machines
Yeah.
are going to be your saving grace
Oh, yeah.
for being able to comprehend an AI. Typically, the best hard solution I can never come up with would be for a fighting game or a combo-based game where you have very specific states. You're in an idle, and you press punch, and after punch, you can do hard punch or soft or light punch, whatever game you're playing. And then from there, you can do, it's like a tree, basically, or a chart, a flow chart that just kind of tells you what you can do at any point in time. And having your animation or your sprites or your 3D animation tied directly to those states is probably the best way to visualize that and to write it down. I've seen a lot of developers tie those together by using Unity, and Unreal has a similar one too. Unity's animator, where basically you just use the animator as your state machine. Basically, you don't have. Sometimes I've had an animator that's just being informed by my state machine, and they always end up just getting desynced at some point. So just using the animator and attaching scripts to all of your nodes as it goes through the animator to just basically make your AI states and your animation and art one-to-one is typically the best case scenario I've used in the past when getting really complex state machines and stuff like that.
This is going to be the last question I have before I open it up to questions to the floor. But preface that, who uses Unity? All right, the vast majority of this room.
Mm-hmm.
Awesome. This question is geared more towards that. I'm curious everyone's thoughts on Unity ML and how you see that fitting in your project, especially from you, since you're the new kid to the block to it.
Yeah. No, I think it's one of those things where, as with anything in your toolbox, to use Zane's metaphor, you want to make sure that you know how to use it before you start trying to use it. And it was the case with Boyd's, it was the case with anything that I've ever used in any of my games, was I always just did a test sample project that was isolating this one new thing and one new idea and just pushing it to its limits and seeing what can I do with this, and will it even be useful in the project that I'm going for? Which is why I like the project that Jason was just showcasing is really cool and really exciting to see, is that now I have a cool, applicable use of it, because I can see how he set it up and how he made it work in that situation. And so, to me, I'm excited. I think it could fit in a lot of ways, most obviously in the example that he already gave just now, where you can have procedural animation for characters, which will not always feel more natural than hand-animated movement, but can result in more emergent and more interesting behavior. But beyond that, also, I've been noticing that you can use it for such a wide range of things. I want to say, someone can correct me on this if I'm just talking out of my ass, but I want to say, this might have been a rumor, but some company used it to determine whether or not someone was drawing and or building phallic structures in their game.
I have not heard that.
That would definitely be a good use case for machine learning.
But
I would agree.
I want to say that I heard. I don't even want to say the company because I'm going to sound really stupid if I'm really wrong. But but we'll hold our theories to ourselves for now. But
talk for after.
Yeah, you talk about it later and talk about it after. Google it yourself later. But that is another potential use for it. If you are trying to do some sort of community management and make sure that your total creative tool doesn't make people.
We'll say graffiti.
Making graffiti that is grotesque and not good for games, then that's another potential use.
Yeah.
It is, and so that's short for Unity Machine Learning, but they're terming it as Unity ML.
Yeah, I wanted to show that video one more time. The spider video I showed you before was using Unity ML agents. It's really good tutorials. It uses a cutting-edge algorithm to do it all, and really, once you dive into the code, you're really just defining the reward function, is really the word for it, where you just define what's good and what's bad, and it just trains itself depending on what inputs you give it. In this example, sure you can play.
Presentation time.
Yeah, all right. It's my computer's shy today. You got it's basically you give it the joints. I think I was giving it the joints and the position of the head, and it just moves the joints and knows their positions. And so it's just basically a matter of maybe 16 total inputs and outputs that the algorithm is given in Unity. And really, after you give it the reward function, you just kind of set it loose. The first iteration of this, it kind of just always flops on the floor and just starts convulsing around. And then eventually it learns that when it convulses slightly this direction, it gets a reward. So it starts slowly convulsing that direction more until it realizes that if it moves its legs, it goes faster, so it gets more rewards. So it learns moving its legs is the way to go. And so you end up with an optimal solution similar to this one that is part of the process. I'm convinced you could make a whole game out of this just by making the reward function side of it. Just,
There has actually been a game on this. It didn't use neural networks. It used evolutionary algorithms, a different type of deal, but machine learning, black and white.
Yeah.
Way back when.
Right.
Check out Black and White as a case study of that. Is
game
very
is-
fascinating
yep.
to see how they used AI as a core part of the entire game design there. But I wanted to sort of add on to that because I thought of another really great use case of Unity ML that I think I'm going to see, that we're all going to see becoming more and more common as time progresses, which is level design. Because in the same way that you can give rewards for telling this character moving right is good, you can train a Unity ML agent that these abstract parameters is good level design. And then you can have it generate level, and sort of give it manual rewards and tell it, this is good level, this is bad level, this is good level, this is bad level, and train your AI to design levels for your game. And I think it's going to bring in a whole new wave of procedurally generated games. I think PropGen has gotten a bit of a bad rap in recent history due to a couple games, but I think that it's going to make a big comeback when we see how machine learning can actually inform smarter procedural generation and create procedural generation that is more fun and geared towards the player instead of purely mathematical, as in the case of like No Man's Sky and other games like that.
So, on that, you two covered basically all of my thoughts, so I'm going to open the floor up to questions I saw a hand here earlier.
Well, it's in relation to the problem you faced with this spider design, how it's wobbling forward on one leg. Did you ever try including, in addition to the kill state, which is the head hitting the ground, damage states like friction on all
Yes, actually, that's one of the best ways to get a biped or a quadruped to actually get the more optimal walking is by saying you need to use the least amount of force necessary to do every frame of this walking action. So if you don't say that, then it ends up just basically breaking its arms and legs to be able to just hop around, and eventually it just trips and falls over because it just has no limits to what it can do. But once you tell it, no, you have to be as optimal as possible over this 10-second span, then it starts to give you more optimal results.
And the other question is, did you ever use some of the lower class results as weaker enemies, for example?
Enemies like in a game type,
you would take the best version as
Okay.
Are you trying to get it difficulty?
essentially.
So, interesting talk at GDC this past year is Quest for the Galaxy. Young lady Teresa Duringer gave a talk that was about a card game that they did digitally, where they used a machine learning agent to be the AI for their game, and they trained an optimal AI that was nearly impossible to beat. That's cool for top tier players, right? And she identifies this in her talk. That doesn't work for people that are trying to learn and begin. The way to get around this without having to redevelop a different AI, without having to ship more information, because it was a mobile game and the neural network itself took up a large chunk of her memory. So without having to do that, all she did was introduce error based on the decision-making process of the outcome for the neural network. Introduce an error based on what the action would be taken by the agent based on the level of difficulty that the player selected. Simple way, use the same whole structure without having to redo code, without having to have additional memory to create easier AI.
I was more thinking in terms of just having it used for the other iterations, because you've already discussed how you have a lot of fail states.
It's kind of call it when you see it.
Yeah. Yes.
First of all, I wanted to say congratulations on Containment. I thought that was great.
Thank you so much.
I have a question. It's kind of a Westworld question when it comes to AI. How do you get your AI to communicate with other agents within the game to say, okay, the agents are working together against the player?
So I did do essentially that with sort of, yeah, Containment is an interesting example, which for those of you who don't know was the game that we released prior to working on Twin Cop. Containment and in Twin Cop we do have AIs that are communicating with each other. At least that's the way that it appears to the player. And that's the way that, like, there are ways, and I'm like, probably you guys talk about how you actually get AI to talk to each other, but I fake it in some clever ways. In the case of Containment, which is about the growth and containment of bacterial growth. In that case, it's more sort of controlled with a grid of values, essentially, and it just says, like, it uses, is there a bacteria here that increases the chance of bacteria spawning in this empty cell near it? Is there bacteria here? That increases the chance of bacteria spawning over here. And then that sort of makes you think like, oh, this bacteria is growing that way, when in reality, it's just this one big, all-intelligent AI that's just deciding when and where to spawn an AI, spawn a bacterial enemy at a spot. So it just says like, oh, cool, let's put one here because I see it's mostly surrounded with bacteria, so naturally it would grow this way. And in the case of Twin Cop, it's just basically there is a flanking manager on the character, which is just saying, here's a position in front of the player, to the right of the player, and to this side of the player. How many enemies are targeting here? 3? Okay, that's too much. You target over here. You target over here, and just sort of like manages the enemies. And so usually for my use cases, it's been let's have a manager tell everyone where to go instead of them talking to each other. But yeah,
that's typical, common in most areas. Either a manager or supervisor is giving high-level instructions, and then if you have it set up that way, lower-level AI are taking those high-level instructions and making decisions of their own.
Yeah, and I also want to add that having agents work together independently is probably about as cutting edge in the AI field as you can get. If you want to see how that's going, though, greatest example is the Dota 2 OpenAI team. That's based specifically what they're doing. For those who don't know, OpenAI made a Dota 2 bot that is capable one-on-one of beating the greatest players. They actually eventually got the very best #1 player at Dota 2. One-on-one cannot beat this bot. And
they're starting to work on teams.
Yes, and Teams is what they're working on now, because Teams is much harder. And
Yes,
if you want to see cutting edge, to keep up with the OpenAI Dota 2 team. Yeah.
Yeah, I was formulating kind of like a related question along the same lines, but I'm kind of a beginner with AI, but I've been experimenting with like decision making, like with FSMs and behavior tree and stuff. But I wondered if there was anything specifically for groups of agents that, like supervisor sort of, like if there were techniques that were commonplace and had buzzwords or something associated, or they just use the same sort of behavior tree except in a supervisor role?
The supervisor is typically going to use a behavior tree. This is going to be, we're talking about this style. Really, it's a two-tiered architecture. So you can insert any other type of AI into those, but it's the architecture of it. You have one guy that's doing one set of state machines or ML or whatever else that is then dictating information down to lower-level entities, whether those are state machine driven or ML driven or other methods. So it's just a structural architecture, and that's really it in most cases.
something worth Googling and researching if you want, if you're more curious about this kind of stuff, is the AI that they set up for Left 4 Dead 2. Which is essentially that. It's a manager that handles when and where to spawn zombies to create the optimal zombie survival experience. It's brilliant what they set up there, so I highly recommend checking that out. I think he was next over there.
We are at 2:59. Any other questions? You guys can come up and check us out. And thank you guys so much for attending and listening to us ramble.
Thank you very much.
Thank you.